Hello, in this video, I'm going to show you how to visualize pre and post-event satellite images of the Morocco earthquake through the Maxar Open Data on AWS. And so the earthquake struck Morocco in last week, September the 8th. So it's only a couple days ago. It was a 6.8 magnitude earthquake, and it was measured disaster. So right now, so far, over 2,000 people have died because of the earthquake. And you can check the map, see the impacted area of the earthquake. And so in order to see what's the impact, we can use satellite images to see how many buildings, for example, what's the area. And Maxar Open Data program provides some of those images before and after the earthquake. So in this video, I'm going to show you how to visualize that easily with some open source packages. So first, you can go to my GitHub repository. So here, I will show you some of the links where you can get access to the data. So the first one is the Maxar Open Data, so the data catalog. If you open the link, it should take you to this website. The link is also in the video description below, so you can access the link directly if you want. And so Maxar Open Data program provide pre and post-event high-resolution satellite images in support of emergency planning. So it's free and for you to use and credit to Maxar. And you can also read more information about the Maxar Open Data program. If you want, you can go to the page. And once you go through the page, I think you might need to sign up. But the data also are also available, for example, on AWS. So if you are familiar with AWS, you can directly access the data. So these are in the S3 bucket. So you can, if you want to retrieve all the data all at once, this might be the easiest way to go. But you will need to be able to use AWS. Also, it's available as a special temporal asset catalog. So if you want, you can access, for example, the link here, and this give you kind of the list of all the images for all the natural disasters that provided by the images provided by Maxar. So specifically for this one, we're going to look at the Morocco earthquake, September 2023. And once you click, you should be able to see basically the directory. So these are all the special temporal asset catalog. If you click in, and then it's kind of like a hierarchy, so you can navigate. You should be able to see all the images. I think it should give you the preview, so like this, so you can zoom in to see. But you cannot see all the images altogether, so you cannot see all the footprints, so it's kind of inconvenient. Also, you might want to download the images. If you want, you can click the link, and then all the assets here. Then if you click in, it should allow you to download the images to your computer. So also you can do, for example, the visualize. This one is just the RGB, but you also provide multispectral imagery. If you want the original one, you can get access to the link in here. You just need to basically replace, this is just visual band RGB, but you can also have the panchromatic band and also the multispectral band. So I'm going to show you how to easily you can download the imagery and get access to the data with LeafMap. Okay, so this is the spatial temporal asset catalog. We can also do query interactively in LeafMap. And so the next one I'm going to show you, I will show you some example how to access it using a code, but I want to show you an interactive web app. So if you go back to the Open Geospatial Solutions GitHub webpage, here, scroll down to the web apps. There's one Solara Maxar. So I created the web app using the Solara Python package that allows you to create web apps using Python. And they also support IPyWidget and DeepMap, so it's very easy to use. Once you're here, upper right corner, you just click the link, so you can open the link to take you to the web page. This is pretty simple and basic one, but it does the job, so you can actually help you visualize all the images. So right now, this is the one that I created, Morocco here. If you click the link, it's automatically load up all the images. And this actually come from the Maxar Open Data repository that I created here. So this repository is being updated daily. So if there are images, new images being released by Maxar, it will automatically update in here. So what you can do is go to the dataset directory. And then if you scroll down to find a file, so it'll be Morocco earthquake. So this is a GeoJSON. So this one basically shows you all the footprint, kind of similar to what I here in the web app, right? It's the same data set, so it's come from here and just displayed it on the map. And also you can have access to just the CSV file. So I'm going to go to Morocco again, September 23. So this one is the TSV, so tab delimited value. And you can see we have date and time and the platform, so you can see all the information. If you scroll down all the way to the end and then scroll to the right, so on the right here shows you the URL. So this is the visual, just the RGB. But if you want the multispectral, you just replace the visual with MS. Then you should be able to download get access to a direct link to all images. So right now there are in a total of 882 images, and you with the WorldView 2 sensor, so 84 centimeter. You scroll up to the up, you can see the column. And some of those actually have 46 centimeters, so it depends on the sensor, and you can get all the information here. One critical one is the date and time. So we want to figure out whether the image is pre-event or post-event. So because the earthquake struck Morocco in on September the 8th, so you want to find images actually is around 2023. So August 28th, so those are the pre-event images, and after that, these are all the post-event images. So if you want to download images in to compare them, you can separate them. I will show you how to do that later. But for now, let's go back to the web app, and this is where you can actually visualize the data set. Upper right corner here, there's some, for example, you can click this one, you can turn the data layer on and off, for example here, and you can click again to hide layer control. The second one is just select the event. So this one actually is not specifically to Morocco, but you can choose any other event. So I'm going to use Morocco earthquake, and then from there you can choose some of the images. So these are basically the catalog ID. You can think about some of those images here. They is by a smaller tile, but it'll be easier for us to actually create a virtual mosaic. So I will show you later. So what this one is doing. So these are basically all the virtual mosaic of the images collected roughly at the same time, and you can easily visualize them easily. So if you have your mouse here, lower right corner shows you when you hover your mouse, what's the attribute of that polygon, right? So some of those actually is September the 9th, maybe it's after the event, and there are also some before the event. So here you can select the drop down list to find some of the images. If you want, you can hover your mouse, for example here, and then you look at the image ID. So if I hover my mouse, take a look at the one on the right here. So this will be the catalog ID, and this will be the date and time. So this one is September the 10th. Certainly it's after the earthquake. And so if you want to visualize the images within of this one, so you look at this ID. So look at the last one is 8000. So if you scroll down here, you should be able to find EA00. So it's this one. So I'm going to select this one and then take a look. Now it's here. And because of the footprint, it's kind of overwhelming. So you can click this button to hide the footprint. And then you can zoom in to the location to see more details of the earthquake destruction. So if we zoom in all the way in, now you can see the images in here. So this one shows you right now the area, and you can certainly see the building. Some of those are destroyed. If you want to compare, so there are two ways you can do that. The first way is to click this one, and then to turn on the Google satellite base map. So if you check this one, and then you turn on and off, now you can see clearly there's some shift because those images might not also rectify very well, so there might be some ground shift, but you can certainly see the buildings, and this is before and this is after. And you can also use the slider here, upper right corner, so you can change the opacity, so kind of a blend those two images together. So in this way you can see very destructive. This is one way, and the second way is using the split map. There's a button here, checkbox. If you click the split map, it will turn this one into side by side. So now you can also do the sliding. You can compare. So you're welcome to explore other area. Once you're done, you click the close button, because right now this one you cannot drag and drop. It's just do the sliding. So if you close this one, and you can navigate to other locations. And this is one of the most damaged location, but there might be other more. You're welcome to share it on social media. So I can show you, for example, here. This is another one. The quality is not as good as the Google-based map, but you can at least see something. So here, for example, in the center, some of those are damaged, and maybe in this another region here. And you, again, you can click the split map, and now you can see this. So try to utilize that and see if there's you can find any other severely damaged area, maybe something in here. So, but this is where you can actually visualize data. Again, I can turn on the footprint again to see the area. So this all the images submeter level Maxar Open Data is pretty good, and you can also look at some other pre-event images, but you can just use Google Earth. Those most likely are before the earthquake, so we can compare them side by side. But you can also look at other, for example, other events if you want. Okay, so this is how you can visualize the images before and after the earthquake using this interactive web app. So if you don't know how to do coding, this might be the easiest way that you can visualize the data all together without having to worry about how do you actually get access or download the data. Next, I'm going to show you how you can actually download the data, and if you want to analyze that or you want to import into desktop.js, you can also do that as well. It's pretty straightforward. I'm going to show you how to do that. So what you can do is go to the repository, and then again go to the Maxar Open Data program. So within the directory here, examples, I created one, Morocco earthquake.ipynb. So what you can do is actually download this one to your computer, or you can also open using Google Colab if you don't want to install on your computer. And so for me, I'm going to just click the button and to download this one to my computer. Save. And now it's under my directory here. So I can use, for example, I can open using Google Colab. So here, I'm just going to conda activate Geo and then Jupyter Lab. Of course, you need to install the conda and the environment, but this is all very basic, so you are welcome to try it out. So once it's open, and then you can double click to open the notebook. If you have time, you can read through the description. These are some of the links that I already showed you earlier, but I'm just going to go straight into the coding examples. So first, I'm going to import a leaf map. I'm just going to use a volume, so less likely to run into problems. Sometimes IPyLib they have some issues. And the first one you want to find is the Maxar collections. So you want to find out, for example, all the data. So it's pretty quick. So take a look at this one. So these are all the Maxar Open Data. So for some of the events that they are provided, and it's the same as the web app. So if you click here, so basically retrieving all of this, and it's coming from here. So if you go to the Maxar Open Data, there's a CSV datasets.csv. So I already basically crawled all the data set. So right now it has 27. So and also tells you how many images within for each event. So for the Morocco earthquake, so right now we have 882. There might some other events that have more images. And the Maxar collections, the function basically is reading the CSV and then return the name of the list. And with that, then you can identify the name for the specific event you want. In this case, we want the Morocco earthquake, and then you just call this function maxr.trial collections. So this is basically the collection that we want, but it has a lot of nested collections in there, just like the this one I showed you earlier, right? So if you go to the earthquake collection, and then there's one, and then if you click in, there are more. So it's kind of a nested hierarchical structure, but you can use it directly using this function. So it's going to retrieve all the collections. So if you run this one, it's going to tell you how many collections in there. So here we have 22. So this 22 is actually from the web app here, and this 22 catalog. So basically, each one is all the images acquired roughly at the same time. So you might, for example, here this might be pretty much similar in here in the same time. So once you grab this one, you can take a look at all the ID. I saw the ID, and this give you the 22 basically mosaic images. So you can think about the these are all the virtual mosaic, and then you can get each individual one. And for example, we can get this one. So the try ID, you can get whatever, just select whichever you like, and then replace this one. And the assets, we are going to just get the visual, but you can use the MS or the panchromatic band. It's up to you. So it's going to take some time to crawl the data set, and it's going to show you how many images within this catalog ID. So here, 5 rows, 21 columns. So that means, oh, this is, I only provide the head, but you can, if you provide the entire geodata frame, you should be able to see all the images. So this is 21 columns. And again, if you scroll to the right, here, the right shows you the column, the visual, basically the last, the URL to that, to each image, right? So specifically for this catalog ID, we can get all those images. And I can show you, for example, earlier we used this one, the EA000. So let me come back to here just to show you how to access that. So you'll be this one, right? So this is the one that we visualize on the map. I'm gonna copy this one and then paste here, run it again. Probably can create a new call block just to show you in total how many images. So it's just going to crawl all the data. It might take a couple seconds. And once it's done, you can see print out the first 5, or you can print out all of them. It's up to you. Once we have this, basically this is the image collection, the collection, or you can visualize that on the map. So it's going to return, for example, as a geodata frame, and then the geodata frame can be directly loaded to the map. It's taking a while, so because it might be, I'm not sure how many images in here. So basically it's getting all these images in here. So probably has maybe 20-30 images available for this virtual mosaic. So it's going to get all the images, go to all the links, and then it can provide you the data frame. So here, take a look. So now we have this data frame, and again, you're welcome to maybe print out the entire one. We're going to show you 70 images. Okay, so it's a whole lot more than what I guess. So 70 images, 21 column, and now with this, we can add the data frame to the map. So just create an interactive map and then use add GTF, and then just add this one and take a look. Let's run it. Right. So this is exactly the same as the one I show you on the web app. So, and the web app under the hood is actually using this one, but it's much faster because I already create a GeoJSON. So if you go to the open data program, the GitHub repository, and then go to the data set, inside there you go to Morocco earthquake, and so these are all the data set that I already pre-built. And if you want to try to find, it'll be whatever, I think EA00, like this one here. So the GeoJSON. So it's basically directly read the GeoJSON. So in that way, it doesn't have to read through the entire catalog, and just basically add these images to the map. This is where the web app is using. But for the source code, I'm showing you how this one was returned. So basically, it's querying the spatial temporal as catalog, and then get all the data set. If you click your mouse, it should pull up all the information. So the date time, basically what's showing up on the spreadsheet is going to coming up in here. And this is also the URL. So this is the direct link. You can actually open it. It should pop up and ask you to download. So this is how you can download the dataset if you want to just do it for 1 or 2. But it might be too time consuming if you want to click one by one, because they say you want all the images for, because these are all the post earthquake images. You want all of them all together. There are 70 images, right? Just like I'm showing here. Then after you visualize, you can get all the links. You can download them all together. So this is what this one is about: the geodata frame and the visual column, and then get the list. So if you run this, now you see the links, right? So these are the links belong to the same collection ID, the catalog ID, and basically it's just a quad key. So it's just a small piece, and with all the links, now you can download that automatically. So you can use the div map Maxar download function and then just passing the list of links. So if you want all of them, it would be just like images, parentheses, right? So this is going to have all the links and then it's going to download them automatically. Just for the demonstration, I'm just going to maybe just download just 2 images, right? So I'm going to download, for example, this link and this link, but you can maybe 3, okay? But you can download all the images for all the data set. You just need to get a column. So I'm going to run it. So take a look. It's going to show you download images 1 out of 3. The nice thing about this is because these all belong to the same catalog ID, and it's going to create a directory. So now if you see on my left side, if you double click, you should be able to see the images. So now I'm downloading the second one, and these are not too big. It's 3 megabyte, 19 megabyte, and 4 megabyte, right? So all the images right now belong to this same catalog ID have been downloaded. Like I said, you're welcome to download all of them. So it's just passing the variable, then you should be able to download all of them. If you want to download tons of data, you might be just using AWS S3 bucket. You can grab the entire bucket, but this allows you to filter the data before you download it. And so this is how you visualize the images. And the next one here, I'm going to show you how you can actually visualize the virtual mosaic, right? So earlier we just showed you the footprint. So the footprint, when you go on the website here, right? So there's 3 files on the left side. So the GeoJSON is just the footprint. The doc.json, this is a mosaic JSON. So the mosaic JSON basically is a virtual mosaic of all the image tiles. Kind of like in here, right? This one has 70 images. And so all the links at the end here. So these are all the images. So you can visualize them one by one, but it'd be nice to create a virtual mosaic that I can visualize all the data all together. So under the hood, we're using T-Tiler. If you're not familiar with T-Tiler, you can Google it. So T-I-T-I-L-E-R. So this is a package that allows you to, it can create the endpoint that allows you to visualize images on the fly. And so I'm going to come back to here. So I'm going to show you this one. So this is basically the JSON. So this is the file path to the virtual mosaic. And we can just call the function add stack layer, then passing the URL, then give it a layer name. Then I can also overlay basically the footprint on top of the images. And maybe let's try to use the same one. So I'm going to use the same one that I used above, using the same ID. So you'll be this one, okay? And then come back to here, replace this one, and shift enter to run it. So we're going to create an interactive map, and then it's going to add to Google set type based map. Also, I'm going to add the mosaic layer and also the footprint. So now you can see, you probably need to turn off the Google set type based map so you can see that, and also the footprint. If you zoom in, you should be able to see the image. It's loading. So again, I'm going to go to the same location that I showed you at the beginning, right? So this is eventually how we create a virtual mosaic. If you want to create by yourself, there's a function here, create mosaic JSON, and then just give a bunch of images on your computer, and then you can output this one, and then you just put the output GeoJSON somewhere that is accessible through the HTTP URL. Then you can render it using the T-Tiler. So take a look at this, and you can turn the layer on and off. Kind of similar to the web app that I showed you earlier. You can use the slider, or you can use the split map, right? So this shows you how to visualize the entire images with all the footprints. So this is a virtual mosaic, but under the hood, it's 70 images mosaic together, right? But you are welcome to download them all together. For those of you who just want to visualize it on the web, then this might be the way to go. So you can combine some programming, and you can specify which one you want. Of course, you can use the web app, right? You can just select this one. You can select the other one. It should be also be render all the images all at once for you. And then you can turn on the data layer. You can split and see the changes. So this is how you can select the virtual mosaic. Next, I'm gonna quickly show you how you can load all the images, all the footprint, right? So this is earlier I show you is the entire all the footprint for all the images that provided by Maxar. So like I said, there are 882 images. So you can scroll down and then come here. So this JSON, GeoJSON is the one on the web page. So you come here and then data sets and scroll down. There should be a Morocco earthquake September 2023 in GeoJSON. So this is the file that's being rendered here in Jupyter Notebook. And so if you can also convert the GeoJSON to geodata frame. So just call this function and then you can print out kind of similar to the TSP I showed you earlier. But all the data set are being listed on the same CSV. Sometimes you might want to figure out exactly which images are taken before, which one are after. So what you can do is look at this date time column. So the date time column has the date and time, acquisition time for the images. And so you can from 2021 all the way to 2023 September the 10th. So what you can do is to do the filtering. So this is the data frame, geodata frame we're using, and we want to select the date time less than September the 10th. As I showed you earlier, right? So some of the images were acquired before that, some are after. So you can look at this column here. Basically, it's already sorted. So all the way, you scroll down, the 882 images. So you can scroll down all the way until you find September the 10th. And some others are like August 28th. So those are the before. And so the cutoff line is here. So 531 and then starting with 32. So this is how you can do that. But this is just a CSV. If you want to visualize that on the map, then you will need the geodata frame or the GeoJSON. So here we just filter, find out all the images before, and you can run it. Like I said, 531 images, and you can print out, right? So take a look at this. September, 2021, December 27. So these are the before, and you can do the reverse, right? Greater than September the 10th. Then see how many images, 351. So we have more images before the event and has 331 images after. And again, you can see the header. This is the first one, September the 10th and 2023. So this is date time. With those two data frames, now we can add both of them together on the same map. So if I run this one again, now you should have the data frame. So the blue color by default, this is the before and is the using blue color. And so in order to better distinguish the time, so I changed it to the red color for the post earthquake images. So what I did is define a dictionary, the color used to red, and the field opacity is just 0.1. And then so passing the style function to volume. And so this function is pretty much the same as the previous one, except now I add the style function. So this is how you can actually change the color. You can zoom in, you can zoom out, and you can hover your mouse, you can click to show you, right? So this one is September, July 14th. If you click the other one, right? So this is September the 10th. So all the red color are the post-earthquake images. All the blue color are before the earthquake. And then you can turn all the data layer on and off, right? So like this. So this gives a much better visualization. So rather than put all of them together, so you don't know which one's before. And once you figure this out, then you can easily download all of them. So for example, you want to download all the post-event images. You don't need a pre-event. Then what you need to do is to actually go to this column. So here, right, the after, and show you. So what you want after, a square brackets, and then visual and comma, right? So this give you all the links, and then you'll be values. Okay. Dot to list. Now you get access to the links, right? So these are all the 331, 51 images. And if you download them all at once, so I can show you, for example, you'll be deep map dot, let me change this one to available so it's easier. So what I would do is to maybe change the ones to links equal to, okay, and then link, for example, I just want to print out maybe the first three, right? So then you can just use max leave maxr download, okay, and then what you can do is just the images. So this will be the things. For example, I just want to download not all the 351, just to post 3 images, and just click one. Okay. So kind of similar to what I showed you earlier. Now it's creating a new catalog ID because these five, if you look at them, they're kind of similar. The cat ID, only difference is here, the quad key ID. So you download it nicely, and once you have this, you can easily open using desktop.js, QGIS or ArcGIS, whatever, and then you can load the data to the map. So I can hold here, open, and then open maybe Google Map. Okay, so then I can come here, look at whatever images there, just download it and drag and drop to the map. Then zoom to the data layer. Right, now you can see differences. I can turn the layer on and off. So this is how you can download, visualize images, download them. Of course, you can do some analysis, image classification, something like that to basically do change detection. So if you have time, I might create another video show you how to, for example, detect all the buildings using deep learning. So might be sometime in the next couple days or next week. So stay tuned. I hope you find this useful, and I will see you in the next video. Take care. Bye bye.